When they found that ancient Greek computer thing, incredibly complex, and it took a long time for them to figure out what that even is.
It sat at the bottom of the sea for 2,000 years, rusted, broken, and forgotten. But when scientists finally pieced it together, they realized it wasn't just old, it was impossible. The Antikythera mechanism shouldn't exist, not with its precision, its gears, or its eerie accuracy.
Very few of these have been found, and it may be that ship owners and navigators in Greek times were extremely careful about who they shared this technology with.
And now that we've cracked its code in full, what we've learned doesn't just rewrite history. It raises a question no one's ready to answer. This isn't just a discovery, it's a warning. The discovery that history tried to bury. It was the kind of discovery that changes everything, not with fanfare, but by accident. In 1901, a group of Greek sponge divers plunged beneath the surface near the island of Antikythera, searching not for relics or riches, but for sea sponges. The waters were clear, and so was the dive routine. What they didn't expect was to find themselves staring at the scattered remains of an ancient shipwreck, a vessel that had been sitting silently on the seabed for nearly 2,000 years. At first glance, it was a treasure hunter's dream. Marble statues, gold coins, amphorae, and ancient ceramics lay tangled in seaweed and encrusted with salt. This was a Roman-era cargo ship, likely sunk sometime around 60 BCE, transporting luxury items from the Greek world to wealthy Roman elites. Every artifact the divers pulled to the surface was valuable. Some were priceless. But none of those glittering finds would prove as world-changing as the strange, corroded lump that barely caught anyone's attention. Roughly the size of a shoebox, it was made of bronze and wood, so fused with rust and marine growth that it looked more like a barnacle-covered rock than a breakthrough. The divers brought it up with the rest, unaware they were holding the most advanced piece of ancient technology ever discovered. For a while it sat forgotten in a museum storeroom, quiet, unimpressive, and completely misunderstood. That changed in 1902 when archaeologist Valerio Stais took a closer look. Turning the object over in his hands, he spotted something that shouldn't have been there. Tiny, complex gears locked together with mechanical precision. Gears weren't supposed to exist in devices from that era, at least not like this. This wasn't just a fragment of a tool, it was something far more complex. This sparked interest among archaeologists. As experts began examining it more seriously, the full picture started to emerge. This device, later named the Antikythera mechanism, was a mechanical calculator designed to track the movements of the sun, moon, and planets. It could predict eclipses, mark lunar phases, and even track ancient Olympic Games cycles. And it had been built more than 2,000 years ago. Its design wasn't simple either. Dozens of interlocking gears, some with teeth as fine as a modern wristwatch, worked together in a compact framework of staggering complexity. Nothing else like it would appear for over 1,000 years. It was as if someone had dropped a modern machine into the ancient world, only for it to vanish again. This wasn't a one-off marvel made by mistake. It was proof that ancient engineers understood mechanical principles far more deeply than we once believed. It asks the uncomfortable question, how much knowledge has been lost to time, and how different might our world be if it hadn't been? The world's first computer, explained. When scientists realized what the Antikythera mechanism could actually do, it wasn't just surprising, it was deeply unsettling. This wasn't some mystical object or ceremonial artifact. It was a precision tool designed to track celestial movements with a level of accuracy that shouldn't have existed in the ancient world. And yet, it did. Roughly the size of a shoebox, the mechanism was made of bronze and mounted in a wooden frame, originally housed in what would have resembled a clock case. But calling it a clock doesn't do it justice. This was a fully functioning astronomical calculator, capable of predicting solar and lunar eclipses, the positions of planets, phases of the moon, and even the timing of the ancient Olympic Games. All of that, controlled by a simple hand crank. Inside, a complex system of over 30 interlocking gears worked together to bring the heavens down to Earth. When the crank was turned, each gear interacted with astonishing precision, displaying the position of the Sun, Moon, Mercury, Venus, Mars, Jupiter, and Saturn, all 5 planets known at the time. Another gear controlled a lunar phase dial, shaped like a spiral, showing the moon's waxing and waning across its monthly cycle. A separate dial predicted eclipses using the Saros cycle, while yet another captured the Metonic cycle, a 19-year period that harmonizes solar and lunar calendars. The gears themselves were astonishing in their construction. Some had teeth so fine and tightly cut they resembled parts from 18th century pocket watches. That level of engineering, in a device dated to the 1st century BCE, left researchers dazed. It suggested not only that someone had figured out the math behind astronomical cycles, but that they had the mechanical skill to build a machine that made that knowledge usable. Inscriptions found on the device, written in ancient Greek, served as both instructions and explanations for how the mechanism functioned. These texts weren't just decorative. They proved that the people who built and used this machine understood what they were doing. They weren't stumbling into discoveries. They had a system, a design, and a purpose. What's even more intriguing is what this machine represents: a forgotten tradition of scientific and mechanical exploration that likely didn't begin or end with this one artifact. If the Antikythera mechanism survived, what else might have existed and been lost? This wasn't a one-time miracle or a lucky fluke. It was the product of a culture that blended engineering, astronomy, and mathematics with stunning sophistication. And it forces us to reconsider how advanced the ancient world really was, because this isn't just the world's first computer. It's a time capsule of brilliance that somehow slipped through the cracks of history. The mystery that refused to be solved. For decades, the Antikythera mechanism sat like a riddle wrapped in rust. It was clear from the beginning that this wasn't some common trinket pulled from the depths. It was something far more advanced than anyone had anticipated. Yet no one could figure out exactly what it was. The craftsmanship was breathtaking. The gears were too precise, the arrangement too calculated, and the fact that it came from a shipwreck dating back to around 60 BCE. That only deepened the confusion. When the mechanism was first studied in 1902, experts were at a loss. Some assumed it was nothing more than an old astrolabe or a tool used for basic celestial measurements. Others believed it might be a navigation device used by ancient sailors or a decorative item owned by a wealthy Greek collector. But none of these guesses truly explained the machine's inner workings. The gear complexity alone shattered the idea that this was something basic or ornamental. The problem wasn't a lack of curiosity, it was a lack of technology. In the early 20th century, researchers didn't have the tools to peek inside without damaging the fragile relic. They could only examine its surface, noting the corroded wheels and fragmented inscriptions that offered more mystery than clarity. That changed in the 1970s, when scientists finally had access to early X-ray imaging. What they saw stunned them. The interior wasn't a chaotic tangle of metal. It was a carefully designed network of more than 30 interlocking gears. Some were smaller than a coin, yet carved with a level of precision thought impossible for the ancient world. One researcher, staring at the scan results, famously likened it to finding a jet engine in the ruins of a horse cart. Even with this breakthrough, understanding the mechanism remained frustratingly out of reach. The gear arrangements didn't match any known models from antiquity, and many of the inscriptions were too worn to be read. Theories emerged, some grounded in astronomy, others bordering on science fiction. But no one had enough pieces of the puzzle to reach a solid conclusion. It wasn't until the early 2000s that things began to shift. With the development of high-resolution 3D X-ray scanning and surface imaging, a new layer of the device was revealed: one invisible to previous generations. Faint Greek inscriptions emerged, engraved into panels and gear plates. These weren't decorative markings, they were instructions and explanations detailing astronomical cycles and the movement of celestial bodies. Now, for the first time, the pieces began to connect. It became clear that this device wasn't just observing the heavens, it was calculating them. Still, even with this revelation, scholars were left asking the same question: how could knowledge this advanced simply vanish? For nearly a century, the Antikythera mechanism defied explanation. It teased the limits of what we believed the ancient world could accomplish. The breakthrough that changed everything. In 2021, a team of researchers finally cracked a puzzle that had stumped the world for over a century, revealing that the Antikythera mechanism wasn't just advanced for its time. It was operating on principles of astronomy and engineering that wouldn't be fully understood again for nearly 2,000 years. A research team from University College London released a stunning reconstruction of the device's gear system. Using advanced modeling software and detailed CT scans, they managed to digitally piece together the internal mechanics. Their reconstruction demonstrated that the mechanism didn't just follow the moon's simple orbit, it also accounted for its complex, fluctuating speed, something modern astronomers call the anomalistic month. Even more impressive, the mechanism could forecast eclipses, down to the precise hour, using gear ratios that mirrored the Saros cycle, a calculation previously thought to be beyond ancient capability. As if that weren't enough, 2023 brought another revelation. A new generation of X-ray imaging, far more precise than anything used before, uncovered inscriptions so faint they'd remained hidden for millennia. These etched Greek texts weren't just notes, they were technical guides, detailing astronomical cycles, planetary positions, and the alignment of celestial bodies. Some of the phrases even referenced cycles, so advanced they'd only been identified in recent centuries. The device wasn't just imitating the sky, it was calculating it, and with a depth of knowledge that no one expected from a world that predated the telescope. Then came 2024, and with it, the full force of artificial intelligence. By feeding high-resolution scans and gear data into AI models, researchers generated fully functional simulations of how the mechanism operated. These simulations revealed something extraordinary. The device tracked planetary orbits with almost 99% accuracy. Even more surprising was the use of epicyclic gearing, a system where gears rotate within other gears to mimic the odd movements of planets like Mars and Venus. This concept wasn't seen again until the 16th century, during the Renaissance. It was, in every sense, a technological anachronism, a machine so far ahead of its time that it forced scientists to question the very timeline of human progress. The Antikythera mechanism didn't just predict eclipses or track time. It shattered the idea that advanced engineering was a product of modernity. It proved that at least one ancient society had reached a level of mechanical sophistication we didn't believe existed. The forgotten geniuses behind the machine. What kind of civilization produces a machine so precise it can predict lunar eclipses down to the hour without electricity, telescopes, or even glass lenses? The real story of the Antikythera mechanism isn't just in its gears and dials. It's in the brilliant minds that conceived and built it. And that might be the most extraordinary part of all. Evidence points to the Greek island of Rhodes as the likely birthplace of this technological marvel. During the 2nd and 1st centuries BCE, Rhodes was a scenic Mediterranean outpost and a bustling center of trade, education, and scientific thought. It housed one of the greatest astronomical schools of the time, and its streets echoed with the work of mathematicians, engineers, and philosophers. It's no coincidence that Hipparchus, one of antiquity's most influential astronomers, lived and worked on Rhodes. His calculations of lunar orbits and star positions were so precise that some of them found their way, 2,000 years later, into the very mathematics used to decode the Antikythera mechanism. The engineering skill behind the device, however, points to more than just theoretical brilliance. This was practical genius on a level rarely seen. The gears were cut so finely and with such exact proportions that modern watchmakers have been left shaking their heads. Many of the inscriptions revealed by 21st century imaging techniques show deep familiarity with not just astronomy, but mechanical design and advanced mathematics. Some of the terms carved into the metal even match the style and substance of writings attributed to Archimedes, suggesting a possible connection to his school or its disciples. Though Archimedes died nearly a century before the device was likely built, the intellectual ripple of his ideas may have helped shape the hands that made it. Who commissioned such a thing? That part remains a mystery. The mechanism was far too advanced and too specialized to be a mass-market item. It may have been a royal commission, perhaps a Ptolemaic ruler obsessed with astrology, or a prized instrument for a temple priest tracking the heavens. The fact that it fit neatly in a wooden box points to one more intriguing detail. It was meant to be portable, perhaps to be shown off, discussed, or demonstrated to others. It wasn't just a tool, it was a statement of capability. Whatever the case, one thing is clear: the Antikythera mechanism didn't appear out of nowhere. It was the result of accumulated brilliance, shaped by minds whose achievements we're only just beginning to rediscover. The part nobody talks about. In 2024, researchers simulating the full function of the Antikythera mechanism watched it predict eclipses and chart planetary movements with stunning accuracy, based entirely on data from over 2,000 years ago. But what stunned them even more was what came next. Nothing. No other machine of its kind appeared in the centuries that followed. The trail just stopped. That silence is the most unsettling part of the story. The Antikythera mechanism wasn't some lucky accident or curious novelty. It was the result of deep scientific understanding, expert craftsmanship, and a refined knowledge of both astronomy and mechanical engineering. By all logic, it should have marked the beginning of something bigger, a spark that lit the fuse for an era of discovery and invention. Instead, it vanished. No surviving records describe its blueprints. No ancient texts explain how it was used or who commissioned it, and no copies were ever found. For something so advanced, its disappearance is baffling. Theories to explain this technological vanishing point range from tragic to chilling. A study published in Archaeological Science in 2024 suggests that geopolitical chaos, particularly the Roman conquest of Greece, may have played a devastating role. Scholars were displaced. Cities once known for scientific learning were sacked or absorbed. Libraries that stored irreplaceable scrolls were burned to the ground. It's entirely possible that the people who built the mechanism died in wars or fled, taking their knowledge with them. Or worse, it was suppressed by those who didn't understand it or feared what it represented. There's also the unsettling possibility that this kind of knowledge was never widespread to begin with. The level of expertise needed to build the Antikythera mechanism implies it came from a tight-knit circle of elite scientists or engineers. If only a handful of people understood how it worked, then it wouldn't take much. Just one war, one fire, one power shift, for the entire lineage of that knowledge to disappear. We like to think of history as a straight climb, each generation building on the last. But the Antikythera mechanism suggests otherwise. Civilizations can reach dizzying heights, then collapse, leaving only scattered fragments behind. If something so advanced could be built 2,000 years ago and then be lost for centuries, it raises a haunting question. How secure is our own knowledge? We live in a world of satellites, quantum computers, and AI, but all of it rests on fragile systems. If those systems fall, how much would survive? Would we become just another mystery for future archaeologists to decode? The Greeks had a cosmic machine, and they lost it. Are we any more prepared to protect what we've created? the ancient code hidden in the gears. Of all the shocking features of the Antikythera mechanism, one stands out above the rest: a single gear with 223 teeth that could predict eclipses centuries in advance. This was a precision tool built to capture the cosmic dance of the heavens, centuries before Newton, before telescopes, before anything resembling modern science. The brilliance behind it lies not just in its construction, but in the mathematics. It's silently encoded, mathematics that wouldn't resurface for over 1,500 years. Built around 100 BCE, the mechanism condensed an enormous amount of astronomical knowledge into a compact, gear-driven calculator. That 223-tooth gear, for example, wasn't a random choice. It corresponded exactly to the Saros cycle, a period of roughly 18 years used to forecast eclipses. The Babylonians had discovered this cycle through careful sky watching, but the Greeks went a step further. They didn't just record it, they embedded it in bronze. And the device didn't stop at the moon. Other gears within the mechanism tracked the 584-day cycle of Venus with remarkable accuracy. Another gear system modeled Mars' retrograde motion, the strange backward path it appears to take in the night sky. What stunned researchers in a 2023 Nature astronomy study was that the mechanism used epicyclic gearing to achieve this, a method involving smaller gears revolving within larger ones to simulate complex planetary movements. This technique was thought to be a Renaissance invention, yet here it was, fully formed, in a device built when Rome was still a republic. The true marvel isn't just that the Greeks knew about these cycles, but that they encoded them in a way that could be physically turned and displayed. And they did this without high-powered magnification, electric tools, or advanced metallurgy. The gear teeth, some finer than grains of rice, were cut by hand, yet still achieved mathematical ratios so precise they rival the internal workings of a modern wristwatch. How the ancient engineers arrived at these designs remains one of the great mysteries. It required not only astronomical knowledge, but a grasp of geometry, mechanics, and even legacy Babylonian data. Greek and Babylonian scientific traditions rarely mingled, yet here they were, fused in a single machine, working together in perfect harmony. That level of cross-cultural synthesis, that mathematical vision, was more than genius. It was a roadmap. A blueprint for understanding the universe that was somehow forgotten, buried with its creators, or destroyed in the chaos that followed. Echoes from an erased Renaissance. The most unsettling truth about the Antikythera mechanism isn't just what it could do, but what it implies. This complex machine wasn't some one-off wonder from an otherwise primitive time. It was likely the crown jewel of an entire generation of scientific brilliance, the surviving fragment of a forgotten age where engineering, astronomy, and philosophy converged in ways we're only beginning to grasp. Around 100 BCE, the Hellenistic world was bursting with intellectual energy. From Alexandria to Rhodes, scholars weren't just theorizing, they were building. They calculated the size of the Earth, studied the movement of stars, and created mechanical devices that seem impossibly ahead of their time. Eratosthenes, using nothing but a stick and sunlight, came within a few hundred miles of calculating Earth's true circumference. Hero of Alexandria created an early steam engine, the Aeolipile, which spun when heated. A novelty at the time, but one that hinted at a future where steam could move machines. These weren't isolated acts of genius. They were symptoms of a thriving ecosystem of knowledge. The Antikythera mechanism shows signs of being shaped by collaborative minds working with shared tools and principles. In 2025, excavations at a workshop in Rhodes uncovered tiny bronze templates and precision chisels, instruments capable of shaping gears like those in the mechanism. These weren't casual craftspeople, they were specialists, likely part of a tradition passed down in guild-like settings, with workshops producing tools for astronomy, navigation, and possibly even education. Then there's the Archimedes palimpsest, a manuscript overwritten in the Middle Ages, but recovered and decoded in the early 2000s. Hidden beneath prayers and hymns were diagrams of mechanisms and mathematical theories that pushed beyond what we thought ancient minds were capable of. It's not just that the Antikythera mechanism was possible, it's that it may have been one of many. And yet, the trail fades. The Roman conquest swept through Greece with brute force, disrupting these hubs of innovation. Libraries burned, institutions collapsed, and with them, the infrastructure that had nurtured centuries of scientific advancement. The Library of Alexandria, home to perhaps the largest collection of this ancient knowledge, was either burned to the ground or slowly eroded by neglect, depending on which version of history you accept. Either way, the result was the same: silence. We're left with fragments, bronze gears, half-erased manuscripts, and temple ruins, whispers of a time when human intellect reached extraordinary heights. The Antikythera mechanism, then, may not be a miracle. It may be a memory, one that hints at everything we've forgotten and everything we still have to recover. Ancient genius, modern impact. The ancient Greeks may have lived centuries before modern technology, but one of their creations still influences the devices in your hands right now. The Antikythera mechanism is a precursor to the technology we rely on today, a symbol of how human innovation transcends the ages. It's more than just an artifact. It's a blueprint for understanding our past, present, and future. In 1960s America, as NASA's Apollo mission prepared to send astronauts to the moon, scientists turned to the Antikythera mechanism for guidance. The machine's precision in predicting eclipses was adapted to refine models for lunar navigation. Just as ancient astronomers understood the complex movements of celestial bodies, so too did the space race engineers apply those same principles to chart the cosmos. The connection doesn't stop at space exploration. The same principles embedded in the Antikythera's gears, a mechanical calculation of astronomical movements, became an inspiration for early computer pioneers. In the 1940s, innovators working on the first analog computers recognized striking similarities between their machines and the ancient mechanism. Its gear-driven logic seemed like a missing link in the chain that led to the birth of modern computing. And in the 21st century, the mechanism's influence extends to the world of luxury watches. In 2013, Swiss watchmaker Hublot unveiled a limited edition wristwatch that echoed the design of the Antikythera mechanism, using tiny bronze gears that mimic the ancient craftsmanship. This collaboration between the ancient world and contemporary engineering shows how timeless ideas can inspire future creations, proving that the mechanisms of antiquity are still relevant today. The Antikythera mechanism's legacy doesn't just belong to the world of science and engineering. It has woven itself into modern culture as well. It's a central plot point in films like Indiana Jones and The Dial of Destiny, where it's portrayed as a powerful, time-altering artifact. In video games like Assassin's Creed Odyssey, players unlock its secrets, blending historical intrigue with digital exploration. While these depictions are fictional, they reflect a deeper fascination with the mechanism's mystique and the tantalizing possibility that ancient civilizations may have known more than we've given them credit for. At a more profound level, the Antikythera mechanism also offers a lesson in the fragility of knowledge. Its survival against all odds, a shipwreck that preserved its brilliance, serves as a reminder that progress is not permanent. Today, scientists advocate for open science, encouraging knowledge sharing to prevent the mistakes of history, ensuring that future generations don't lose what we've built. So, as you hold your smartphone or check the time, remember that the foundations of these inventions were laid by minds from another era. The Antikythera mechanism isn't just a relic of the past, it's a bridge to our present and a challenge to our future, inviting us to continue creating, learning, and preserving the wisdom that can shape the world. The story of the Antikythera mechanism is a snapshot of an ancient world teetering on the edge of a golden age. A chilling discovery in 2025 when divers recovered pottery and bronze fragments near the Antikythera wreck hinted at the existence of more such devices, buried under centuries of ocean and sand. The idea that we may only be scratching the surface of a forgotten technological age leaves us with an unsettling thought. How much knowledge has already been lost to time? This fear, though rooted in the ancient past, echoes loud and clear in our modern world. Our technological advancements, from artificial intelligence to space exploration, represent a leap forward in human capability. Yet, these marvels of the digital age are just as vulnerable to disaster as the Antikythera mechanism. A global catastrophe, whether from war, environmental collapse, or a cosmic event like a solar flare, could easily erase the vast digital archives that store our knowledge and progress. Imagine future generations stumbling upon a shattered iPhone with no clue how to reconstruct the marvels it represents. It's a sobering thought, but one that reminds us of how fleeting our achievements can be. The lesson of the Antikythera mechanism is clear. Knowledge, no matter how advanced, is never guaranteed to survive. As scientists work to understand this ancient device, they are pushing for systems that ensure our own breakthroughs don't disappear into the void. Resilient infrastructures, physical backups, and open-source knowledge are all part of the push to safeguard our legacy. If a single forgotten machine from a lost civilization can spark such profound discoveries, perhaps we can learn to preserve what we've created for future generations. The Antikythera mechanism, in all its ancient brilliance, is not just a relic. It's a warning and a call to action. It urges us to protect the flame of human ingenuity before it flickers out, lost to the sands of time, as so much before it has been. Thanks for watching. See you in our next video.